free body diagram question in which we're dealing with simply two forces in a fairly linear direction on a single object. We know our two forces, we can identify them pretty quickly. Force of gravity is equal to mass times the acceleration due to gravity on Earth. Force of tension, we don't know what that value is. What is given is our net acceleration, therefore we can solve for our net force. Net acceleration given as 0.4 meters per second squared as it travels downward. Therefore, we can solve for our net force because we know net force is equal to mass times net acceleration. Net force is equal to 5.12 newtons. We can now solve for our force of tension supplied by the student because logically we can come up with the arithmetic expression net force is equal to force of gravity minus force of tension. This is an equation that's memorized or anything. We just logically come up with it. Force of gravity, we realize, wins because this bucket is being lowered. Doing arithmetic on that, we land on a force of tension value of 122.88 newtons. A quick supplement to questions such as this are, hey, there's a known distance this object is being lowered to the ground. How long does it take the object to reach the ground? You come across these a lot on questions such as this, on questions such as inclined planes. The major steps to take are to solve for your net acceleration. Luckily, that was already given to us in the problem, and then turn this into simply a kinematics question. Kinematics to the tune of, we know this object, or assume that this object is dropped from rest. We know our distance traveled. We know our net acceleration. Not the acceleration due to gravity, mind you. This object isn't in free fall. We can now solve for the time required to reach the ground using the appropriate kinematic equation. In this case, I will use d is equal to VIT plus 1/2 AT squared. Plugging in appropriately. And solving. Once again, the trick to such questions is figure out what your net acceleration is from your force workup, and then plug that in for any acceleration values to make it talk appropriately to kinematics.